Hey everyone, and welcome back to Coffeesodes. Are you ready for deep dive number 9 with us?
I am.
Awesome. Today, we are tackling a topic that is, it's generating a lot of buzz these days.
Yeah.
It's hydrogen engines. Can they really deliver a cleaner future for our cars? And if so, how? We'll be taking a look at some really interesting research today, so if you want to follow along, you can check out the link to the paper in the episode description.
Yeah. It really is a fascinating time right now with all these different paths that are being explored for cleaner transportation. You've probably heard about fuel cell vehicles.
Right.
Those are already on the market. But today we're going to explore the potential of internal combustion engines, or ICEs,
Okay.
that are designed to run directly on hydrogen.
So instead of totally reinventing the wheel,
Yeah.
we're trying to kind of adapt the familiar internal combustion engine to this new fuel.
Exactly.
Why go that route instead of just focusing on fuel cells?
Well, there are a few key advantages to hydrogen ICEs.
Okay.
First, they could be adapted from existing engine designs, potentially making that transition a lot smoother and less expensive.
That makes sense.
Second, they might not need the really complex and costly systems required for fuel cells.
Right.
And some researchers even believe that they could surpass fuel cells in efficiency.
Wow, what?
Hydrogen is a very tricky fuel to work with, and there are definitely hurdles to overcome.
Yeah, I can imagine. It's not like we can just pour hydrogen into our gas tanks and just call it a day.
Exactly. Hydrogen has some very unique properties that make it behave quite differently from gasoline or diesel. The research paper we're looking at today actually has a really helpful table,
Okay.
Table 1, that lays out some of these key differences. It's like a cheat sheet for hydrogen.
Okay, awesome. I'm looking at table 1, and whoa, the energy density by weight is amazing.
Yeah.
Almost 3 times higher than gasoline. But then the density by volume is incredibly low. That's kind of a head scratcher. It's like saying a giant balloon has the same energy potential as a tiny gas can.
That's a great way to put it. And that low volume density is one of the big challenges. With hydrogen,
Yeah.
imagine trying to fit enough hydrogen to power a car into a reasonably sized tank.
Right.
You need incredibly high pressure tanks, which adds weight and takes up precious space.
Yeah, for sure.
And because it burns so differently, we need some really clever engineering to prevent issues like pre-ignition and backfiring.
Backfiring. Ooh, that brings back memories of my first car. Not a good sound. So what makes hydrogen so prone to these combustion problems?
Well, hydrogen has a remarkably low minimum ignition energy.
Okay.
It's almost like it's too eager to ignite. From even the smallest spark or hotspot,
Oh, wow.
this can lead to pre-ignition,
Yeah.
where the fuel ignites before the spark plug fires, causing uncontrolled combustion.
Oh, okay.
And since hydrogen burns so rapidly, it can easily backfire into the intake manifold, especially in engines designed for port fuel injection.
So port fuel injection,
Yeah.
which is pretty standard in most cars today, isn't ideal for hydrogen.
Not really.
So what's the alternative?
This is where things get really interesting.
Okay.
Direct injection, or DI, is a really promising approach. Instead of injecting hydrogen into the intake manifold, we inject it directly into the cylinder,
Okay.
late in the compression stroke. This gives us much finer control over the fuel-air mixture
Yeah.
and minimizes the risk of those pre-ignition and backfiring issues.
Okay.
Plus, it opens the door to potentially higher power
Mhm.
and efficiency.
So DI is all about precision and control.
Yeah.
But how do we ensure that the hydrogen ignites at precisely the right moment? Isn't that crucial?
Absolutely. There are two main contenders when it comes to ignition.
Okay.
Spark plugs and glow plugs.
Spark plugs and glow plugs.
Think of it this way. A spark plug is like a quick burst of flame from a lighter,
Okay.
while a glow plug is like a steady hot ember.
I like that analogy. So which one's better for this finicky hydrogen fuel?
Each has its own set of advantages and disadvantages. Spark plugs are familiar and widely used,
Right.
but they can be unreliable with hydrogen. Glow plugs offer more consistent ignition, but their durability in the extreme environment of a combustion engine is a concern. Imagine a red-hot poker, constantly exposed to the intense heat and pressure.
Yeah.
That's essentially what a glow plug goes through.
That is a tough choice.
Yeah.
So it sounds like we need a secret weapon to crack this ignition puzzle. Is there something else out there?
There is, and it's a really clever approach called H2DDI.
H2DDI.
Hydrogen diesel direct injection.
Okay.
It's a hybrid system that uses a tiny amount of diesel fuel.
Wait, diesel? That sounds counterintuitive. Why would we bring diesel into the equation when we're trying to go green?
It's not as crazy as it sounds.
Okay.
Diesel is very easy to ignite. Think of it like kindling for a fire. By injecting a small amount of diesel directly into the cylinder, along with the hydrogen, we create a localized high-temperature zone that instantly ignites the hydrogen. This solves the auto-ignition problem, allows for higher compression ratios, meaning more power and efficiency, and could even lead to super clean combustion.
Okay, this H2DDI is starting to sound pretty impressive. But I'm picturing these highly pressurized hydrogen jets shooting into the cylinder, almost like miniature rocket engines. How do we control those jets to make sure combustion is efficient and clean? That seems incredibly complex.
That's where the science of gas jet behavior comes in.
Okay.
We're dealing with highly pressurized supersonic jets of hydrogen, and understanding how those jets behave is critical for optimizing H2DDI.
Supersonic. Wow, that sounds intense. Before we get too deep into the science, let's take a quick break and come back to explore those hydrogen jets in more detail.
All right, so let's dive into the world of those supersonic hydrogen jets.
Okay.
Remember, we're not just talking about like a simple spray of fuel. These jets are very dynamic and complex.
Right.
And understanding their behavior is absolutely key to making H2DDI work efficiently.
Okay, I'm ready for my crash course in supersonic jet science.
Okay.
What makes these hydrogen jets so different from, say, the fuel injectors in a regular gasoline engine?
It all comes down to the incredible pressures involved. We're talking about what are called underexpanded jets.
Underexpanded jets.
No.
Okay, break that down for me. It sounds a bit like a science fiction term.
Imagine a balloon filled with air.
Okay.
When you release the opening, the air rushes out
Right.
because it's at a higher pressure than the surrounding atmosphere. Now magnify that pressure difference immensely.
Okay.
And you have an underexpanded jet. The hydrogen is so eager to escape that it exits the nozzle at incredible speeds, faster than the speed of sound.
Wow, that's mind-blowing.
Yeah.
So what happens when these supersonic hydrogen jets enter the combustion chamber? Does it create chaos?
It's not quite chaos, but it is definitely complex.
Okay.
So picture this. As the jet shoots out of the nozzle, it expands rapidly, and this expansion creates a series of shock waves.
Shockwaves.
It's almost like miniature sonic booms happening right inside the engine cylinder.
Yeah.
These shock waves interact with the surrounding air, creating this very intricate flow pattern
Okay.
that influences how the fuel mixes and burns.
So instead of like a straight shot of fuel, we've got shock waves and turbulence. That doesn't sound very easy to control.
You're right, it's a very delicate dance. And to add another layer of complexity, these jets often hit the cylinder walls.
Okay.
This creates yet another level of interaction that we need to consider. It's a bit like trying to choreograph a ballet in a wind tunnel.
This all seems incredibly complex. How do researchers even begin to study these microscopic supersonic events? It's not like we can just crack open the engine and watch it happen in slow motion.
You're right, direct observation is tough.
Yeah.
But researchers have some amazing tools at their disposal.
Okay.
They use sophisticated visualization techniques, Schlerin imaging, to capture these events.
Schlerin imaging, what is that?
It's like taking a high-speed X-ray movie of the combustion process.
Oh, wow.
These images allow scientists to see those shock waves, the expansion patterns, and how the hydrogen mixes with the air.
So we're using cutting-edge technology to literally visualize sound. That's incredible. But once we have these images, what can we do with them? How do they help us make H2DDI engines better?
That's where computer modeling comes in.
Yeah.
Scientists use these visualizations to develop and refine simulations that can predict how these jets will behave under different conditions. It's like having a virtual lab where we can test out different injection pressures, nozzle designs, and even engine geometries to find the optimal setup for combustion.
So it's a combination of real-world observation and virtual experimentation.
Yeah.
That helps us unlock the secrets of hydrogen combustion.
That's pretty cool. But I have to ask, are there any specific challenges unique to H2DDI that keep researchers up at night? What are the big roadblocks that they're trying to overcome?
One of the biggest challenges is ensuring reliable and consistent ignition of the hydrogen. Remember, even though we're using a tiny amount of diesel as a pilot light, hydrogen is still a very volatile fuel that requires very careful control. So even with the diesel assist, there's still a risk
Yeah.
that things won't ignite properly.
Exactly.
Well, what are the consequences of getting it wrong?
If we inject too much diesel, we increase emissions, which kind of defeats the purpose of using hydrogen as a clean fuel. But if we use too little, we risk misfires and unstable combustion, leading to poor performance. It's a very delicate balancing act to find that sweet spot.
I imagine the timing of those injections is crucial as well.
Absolutely.
It's not just about how much fuel we use, but when we introduce it into the cylinder.
We need to make sure that the diesel ignites first, creating a hot enough environment for the hydrogen to combust completely. If the timing is off even slightly, we might end up with unburned fuel or inefficient combustion. It's like a carefully choreographed relay race. Each handoff has to happen at precisely the right moment.
So it's like a carefully choreographed combustion symphony with diesel and hydrogen playing their parts in perfect harmony.
I like it.
But let's shift gears for a moment and talk about the bigger picture. Aside from these technical challenges, what other hurdles stand in the way of H2DDI becoming a practical reality? What about things like cost and infrastructure?
Those are definitely crucial considerations. Developing and manufacturing H2DDI engines with all of their advanced technologies is still considerably more expensive compared to conventional gasoline engines.
Right.
And that brings us to the classic chicken and egg problem.
Uh-oh.
We need cheaper technology to make H2DDI viable, but we need investment to drive down the costs.
It's a tough situation for sure. And then there's the issue of infrastructure.
Yeah.
We need a widespread network of hydrogen fueling stations for people to actually use these vehicles. Building out that infrastructure requires significant investment and coordination from governments and industry. It's like having a fantastic electric car with nowhere to plug it in.
That's a great analogy. And let's not forget about public perception. People are familiar with gasoline and diesel engines, but there's still some hesitation around hydrogen, particularly regarding safety. We need to show people that hydrogen ICEs can be safe, reliable, and practical options.
So it's a multifaceted challenge. That involves not just the technology itself, but also economic factors, infrastructure development, and public acceptance. It sounds like a massive undertaking.
It is.
What are your thoughts on the overall feasibility of H2DDI, considering all these challenges?
It's certainly not an easy path, but I believe H2DDI has the potential to be a game changer. In the quest for cleaner transportation, we've made significant progress in recent years, and with continued research and investment, I'm optimistic that we can overcome these hurdles and make H2DDI a reality. But it's important to remember that H2DDI is just one piece of the puzzle. The future of transportation is likely to involve a variety of solutions, each with its own strengths and weaknesses.
So it's not about picking winners and losers,
Right.
but about exploring all the options and embracing diversity. In our approach to a cleaner future, it's about fostering innovation and collaboration to find the best solutions for our planet.
Exactly.
And who knows what other breakthroughs might be just around the corner. This has been an incredibly insightful deep dive into the world of H2DDI. We've uncovered the science behind those supersonic hydrogen jets, explored the challenges, and glimpsed the potential of this fascinating technology. But there's still so much more to explore. And we have a lot more to cover in part 3, so stay tuned. Welcome back to Coffeesodes.
We've been deep diving into hydrogen engines and H2DDI. There's huge potential, but definitely some challenges too.
Yes, a bit of a balancing act, wouldn't you say?
For sure.
Trying to harness that clean burning potential of hydrogen,
Right.
all adapting existing technologies.
And infrastructure.
Exactly.
Okay.
And we've talked about some of the technical hurdles, but what about the bigger picture? Will we actually see hydrogen ICEs powered by H2DI on the road anytime soon? Like, what are the realistic prospects for this technology?
That's the million-dollar question. While I'm optimistic about the long-term potential of H2DDI, there are still a few major roadblocks that we need to address before it becomes mainstream.
Okay, give it to me straight. What are the biggest challenges standing in the way of H2DDI, going from the lab to the highway?
Well, as we touched upon earlier, cost is a major factor.
Yeah.
Developing and manufacturing these advanced engines is still significantly more expensive. Compared to traditional gasoline engines,
Yeah.
it's a classic chicken and egg scenario. We need to bring costs down to make H2DDI more attractive, but we need investment and scale to achieve those cost reductions.
It's like a financial catch-22.
Yeah,
We need more affordable technology to drive adoption, but we need that widespread adoption to make the technology more affordable.
exactly.
Okay, so what about the infrastructure side of things? We talk about the need for a network of hydrogen fueling stations.
Yeah.
Is that a major hurdle?
Absolutely. While we're seeing some progress in building out hydrogen infrastructure, it's still nowhere near as extensive as the network of gas stations that we have today.
Yeah.
And this is crucial for consumer confidence.
Right.
They need to know that they can conveniently refuel their hydrogen-powered vehicles.
Oh, sure.
It's like having a state-of-the-art electric car with very few charging stations available.
Right, the range anxiety issue.
Exactly.
No one wants to be stranded with a dead battery or an empty hydrogen tank miles from the nearest refueling station. So aside from cost and infrastructure, are there any other challenges that we need to consider?
Public perception is another big one.
Okay.
While awareness of hydrogen as a fuel is growing, there are still some lingering concerns about safety.
Yeah.
People have heard stories about hydrogen being explosive and may not be entirely comfortable with the idea of it powering their vehicles.
So there's an education gap that needs to be bridged.
I think so.
We need to show people that hydrogen can be handled and used safely in everyday applications.
Absolutely, we need to demystify hydrogen and highlight its benefits. As a clean and sustainable fuel source, it's about building trust and confidence in the technology.
Okay, so it seems like bringing H2DDI to the masses involves this multi-pronged approach.
It does.
We need to overcome technical challenge, reduce costs, build out the infrastructure, and educate the public. It's a complex puzzle with many interconnected pieces.
Yeah.
What do you think is the most crucial piece of that puzzle? Like, what will ultimately determine the success of H2DDI?
That's a tough question, but I'd have to say that collaboration is key.
Okay.
We need scientists, engineers, policymakers, industry leaders, and consumers all working together to make this vision a reality. It's not just about the technology itself, it's about creating an ecosystem that supports its development and adoption.
So it's a collective effort, a shared journey towards a cleaner and more sustainable future for transportation.
Exactly.
And H2DDI could be a significant part of that journey.
I believe so. It's an exciting field with tremendous potential. And I'm optimistic that we'll see hydrogen-powered vehicles, powered by innovative technologies like H2DDI, playing a much larger role in the coming years.
Well, there you have it, folks. We've taken a deep dive into the world of hydrogen engines, explored the intricacies of H2DDI, and considered the challenges and opportunities that lie ahead. It's a complex and evolving landscape. But one thing is clear. The quest for cleaner and more sustainable transportation solutions is driving incredible innovation.
And that innovation is something to be excited about. It's a reminder that we have the ingenuity and the collective will to create a better future for ourselves and for generations to come.
That's a great note to end on. A big thank you to our expert guest for guiding us through this fascinating topic.
My pleasure.
And to all of our listeners, thanks for joining us. For this deep dive into the world of hydrogen engines, we encourage you to check out the research paper linked in the episode description if you'd like to explore this topic further. Until next time, keep those coffee mugs full and those minds curious.